Hi folks, this is Maria, and we're just going to talk about pH and how to actually calculate it. So our goals for the video, just talking about the pH scale and reminding you why we use it, and then to talk about how pH and H plus concentration are related, as well as pOH. So the pH, scale is really just a simple way of comparing acidity. Talks about how much H plus there is in a solution. Do you remember, whenever we're talking about H plus in solution, that it's really just an approximation for the hydronium ion? Just reminding you of that real quick. So if we're talking about a low pH, it means that it's an acid. So remember, that's anything under 7. So anything over here, so under 7. And then a high pH would be a base, so anything over 7. Also remember, pH of 7, neutral. All right, so I'm asking you this question here just to kind of get your mind around something. If I'm talking about adding some HCl to a solution, is the pH getting lower or higher? So a lot of students, when they're thinking about it the first time, they're saying, okay, well, you're adding more HCl to the solution. That means you're adding more H plus ions, so therefore the pH is getting higher. That's incorrect. So the pH is getting lower. It is definitely getting lower. And we'll talk about how the relationship between the pH and the H plus concentration makes it so that that's why the number for the pH gets lower. All right, just a quick thing I'd like to draw your attention to real quick is if you look at the H plus concentration and the pH, you'll see that the number perfectly matches the number up here. The only thing is it's not negative. So that's the only thing that changes. So the H plus concentration, the pH, which is kind of interesting. All right. Okay, this is a quick little disclaimer. So we're only using logs as just sort of a button on your calculator. I know that's not true in other classes. I know I'm definitely oversimplifying it. So if you know what I'm talking about when I'm talking about the log button, I will also tell you we're only using log base 10. You do not have to worry about any other sort of logarithmic stuff. If you're like, Maria, what on earth do you mean? That's okay. We're making it so that you never have had to have talked about logarithms in a math class before. So do not worry. Okay, so now that I've said that, let's talk about how pH and H plus concentration are related. So these two formulas you should definitely write down. So pH is equal to the negative log of the hydrogen ion concentration. And then the hydrogen ion concentration is related back where it's 10 to the negative pH. Okay, so what does that mean? Why do we care? So let's go ahead and take a look at this little chart right here. So when I'm looking at this, what I can clearly see real quick is, and I don't know why this particular figure is labeled with activity. It just means the H plus ions in solution. So if I'm looking at this, what this really means is that a pH of 0 would have like a 1 molar concentration. Whereas when I'm going, the further I go down, that's the concentration of hydrogen ions in solution. And so then that should make a lot of sense why a base has such a very, very low hydrogen ion concentration. There's tons of zeros here, right? So that is something just to keep in mind, why then a pH of 14 would be such a low number. Another thing to just kind of keep in mind is comparing these different numbers. So it doesn't seem like a big deal to change from pH of 0 to pH of 1 unless you think about it in terms of the actual amount of hydrogen ion concentration. So if I'm going from essentially a pH of 1 to a pH of 0.1, that's about 10-fold less, or that is 10-fold less hydrogen ions in solution. So it's just sort of interesting to think about that when going through. People might be like, oh, it's not a huge deal to change by the pH scale at 1 point. It is a big deal. So just keep that in mind. Okay, so pOH. pOH sounds confusing, but it's actually really not. You use almost exactly the same equations. It's not a huge deal. The first thing that you need to know is that pH and pOH are related. This is one of the equations you can use. pH plus pOH equals 14. For me, I essentially gave you a few more sig figs because I don't want this to limit you. But So if you do pH plus POH equals 14, that would be a good equation to write down. So the POH is really just a measure of how many hydroxide ions are in solution. So, as it turns out, very similar to the pH equation. The POH is a negative log of the hydroxide ion concentration. Cool. I would write that formula down as well. And then this is just the last formula that I need you to know. It's actually fairly simple. It's the hydrogen ion concentration times the hydroxide ion concentration gives you this number. So just something else to know when going through and trying to calculate things. POH isn't commonly used outside of chemistry, and it's far more likely that you'll hear about pH. We're just used to it, you hear it a lot more, it's something to be aware of. So if I'm looking at this, you can see that essentially if I have something with a pH of 10, that you know that from your pH scale, yeah, that's a very low, that's a very high pH, and so therefore there's very little hydrogen ions in solution. Well, if I'm talking about it from the perspective of the hydroxide ions, there's a bunch of hydroxide ions in solution at that pH. So it's just another way of relating those two figures to each other. Okay, so you've got all the formulas. We're just going to do a little practice, and we're just going to kind of convert around for different things. All right, so if I have a solution of pH 5.6, so what if I asked you for the concentration of protons in solution? Easy enough. There's this equation, the H plus equals 10 to the negative pH. So I'll just plug in my pH, and then when I plug that into my calculator, this is what I get, 2.5 times 10 to the negative 6th molar hydrogen ions. Cool. Easy. What is the concentration of hydroxide ions in solution? Okay, so that one's a little bit trickier. I'm going to use this formula from before that I showed you. So the hydrogen ions times concentration of hydrogen ions times the concentration of hydroxide ions. And then I'm going to solve for the hydroxide ions because that's what I'm trying to figure out. And I actually already have the hydrogen ion concentration. I already have it from the first part of this problem. So I'll plug that in. And then when I plug that whole dang thing into my calculator, I end up with 4.0 times 10 to the negative 9th molar hydroxide ion concentration. Cool. All right. So POH, there's a few different ways. If you wanted, you could use this at this point to calculate the POH. But I chose, just to kind of like double check myself, I chose to use this. So the pH plus the POH equals 14.00. So then I plugged in the pH and solved for the POH, about 8.4. Okay, cool. So that makes reasonable sense when looking at my hydroxide ion concentration from before. Awesome. Okay. So that's a useful exercise just to do until you're feeling comfortable to go through and play with these different ones. We'll do that in class. That'll be part of what we do. But this is one that's a little more realistic. This is more of what you might need to actually figure out and double check and go through. Okay, so if I have a solution and it's 0.25 molar magnesium hydroxide, which hopefully you're like, oh, hydroxide, that's a base. Okay, so you're probably expecting something basic. So what is the pH? Probably something over 7. So just to keep that in mind. All right, so I'll take the molarity, and I'm just going to convert it into moles of hydroxide ions, because that's what I truly care about when I'm going through and doing this. So I convert it into the moles of hydroxide ions. Okay, so that's my molarity of hydroxide ions. Cool. So if I do that, I'm going to go ahead and then use my POH equation, the negative log of the hydroxide ion concentration. I already know what my hydroxide ion concentration is, so I'll just go ahead and plug that in. I plug it in. This is what I end up getting. So I end up getting 0.3. And then the pH plus the POH equation, I'll use that again, plug in my POH. And so then I would end up getting 13.70. Sounds good. Okay, so if that's my pH, then does that make reasonable sense? Yeah, it makes reasonable sense if I'm looking at the hydroxide ion concentration. All right. So you'll hopefully have fun doing this. You're going to go through and make an indicator. They're colorful chemicals. They just change color in different pH solutions. Follow these instructions. They're also on page 7 in your packet. You just want something that's brightly colored. It does not need to be anything funky. These are all possible plants, beets, blackberry juice, carrot greens, all that sort of stuff is all good. Chop up about half a cup of the plant and then half a cup of water and heat it in the microwave, and then really just keep the liquid, pour off the plant stuff, and then bring that in for when I see you next, or when Becky sees you next. Other than that, we look forward to playing with your indicators. We'll see you then.